So we're going to finish section 13.2 on this video. Your uncle passes away, leaving your 72-year-old aunt with $500,000 in life insurance proceeds. She needs a monthly income and expects to live at least another 15 years. Let's see. If she invests the insurance money in an account earning 5.5% compounded quarterly, how much can she withdraw every 3 months without depleting the principal? So this is an important part of this, right? We don't want to deplete our principal, which means the principal stays the same throughout the 15 years, right? It doesn't change. All right, very important, very important. Okay, so let's start putting our numbers on the chart. And first of all, it's 15 years, compounded quarterly, so it's going to be times 4. 5.5% would be 5.5%, and that's divided by 4, and then equals. The amount going into the account is $500,000. So it's negative, remember, because it's in an account that you can't touch. In the future, we want it to still be $500,000. So the principal does not change. At the end of this 15 years, we will still have $500,000 in the account. So we're going to compute the payment. And that means that we need to push compute payment to figure out what this is going to be. Now this is quarterly, so quarterly your aunt can withdraw $6,875, and then we might wonder, what would that be monthly? Remember, quarterly is every 3 months, so we would divide this by 3 to find out the monthly amount, and it does ask us to do that. How much is this per month? So we don't want to stop yet until we figure that out. So it would be $2,291.67 per month. All right, so that is our monthly amount. But it's every quarter, and so she would have that monthly amount then from that quarterly payment. All right, referring to the previous problem, if your aunt withdrew only $4,950 every 3 months, that is $1,650 per month, what would the balance be in 20 years? All right, $4,950, remember on this previous example it was $6,875. So we're going to complete the chart again. This time it's for 20 years, and it is still quarterly, so 20 times 4. Interest rate is the same, so you could have just left that one on there if you already had it there. Present value is the same, 500,000 negative, because that is in an account. And if she withdraws in the 4,900, and remember, a withdrawal means she gets to keep that money, and it is positive when we enter it on the calculator. And then we are going to compute future value, because it says what would the balance be in 20 years. So that means that the $500,000 is going to grow because we are not withdrawing enough to take out any of the all of the interest, in fact. So interest gets added back in, and that's why we end up with more. So it's $777,443. Whoops. 443.22, right? So that is the amount in the account because the interest is added back in, and that means the principal grows and we get paid on a higher amount for our interest then. Your family talked to your aunt, see the in the above problems and convinced her that she really needed more than $16.50 per month in order to be able to afford her monthly expenses, prescriptions, mortgage, mortgage, insurance, utilities, and so on, right? So we want to make sure that she can afford these things. She has agreed to withdraw $8,400 every 3 months. That's $2,800 per month. How long will her husband's insurance payout last? Okay, so that means that we're going to take the money all the way down to 0. So it's a different kind of problem this time. Interest rate is still the same though. So it was 5.5% divided by 4 because we are compounding quarterly. It's $500,000 is still the amount right in the account, and that's consistent with what we've done in the last couple of questions, right? We're still working with that same amount. Now she's going to withdraw $8,400 every 3 months, and that's $2,800 a month. Future value will be 0. Okay, so we're going to compute in the number of periods. How long will this money last? And the number of periods when you compute on this one ends up being 124.94. Now remember, this is quarterly, so that means that there are 4 periods each year, and we divide this then, divide it by 4, and that would be 31.24 years. So it's going to last her more than 30 years if she withdraws a higher amount, which would be okay, I think, since in the first place, if you remember, she was 72 years old. So I think withdrawing more is a good idea. All right. Okay, next question. Moonbeam wins $156,000 on the Jeopardy game show. So you don't need the TVM keys to answer this part. If Moonbeam withdraws $2,000 per month from her winnings, how long in years can she do this if the $156,000 isn't earning any interest? Well, that just means we can take $156,000 and divide it by 2,000, and that will tell us how many months, right? For 78 months she can withdraw this money. We can divide that by 12 and see that it would be 6.5 years. Now you would for sure want this money earning interest, because you can, you see it's not going to last that long even with $2,000 per month being withdrawn. And so now we're going to check out what happens then if Moonbeam wins the money, but then she puts it in a savings plan earning 5.7% interest compounded monthly. She makes withdrawals of $2,000 at the end of each month. How long in years can Moon make withdrawals until the money is gone? Okay, so initially it was 6.5 years. This time she's still withdrawing the same amount, and so hopefully it's going to go up some because of interest. So 5.7, and it is monthly, so we're dividing by 12. Her present value is $156,000. Her payment is $2,000. That's how much she's withdrawing. It's positive because she's getting that money. Our future value is going to be 0, right, until the money is gone, right? And so then we're going to compute N, and when we compute N, then we can convert that to years to compare that to what was happening with no interest, which you wouldn't want that kind of money sitting around with no interest. So when you compute, you find that it's 97.67, and that is months, right? If we divide by 12, then we find that it would be 8.14 years. So with interest, she gets another year and a half or so to withdraw the money at $2,000 per month. All right, so that is the end of section 13.2.